Let's talk about numerical integration. In this first video, I want to talk only about some basics, some very few basics, and in the next video, we will really go into the numerical integration. There we will talk about an algorithm, an idea how to do the integration. Now some basics about the field of numerical integration. Whichever term function you have, you can derive algebraically. Algebraically means that is the counterpart of numerical. You prefer doing things algebraically, but if it's not possible, then you are glad that there are the numerics. But if you have algebraic methods, normally you will prefer them. So if you are interested in the derivative of sine of x squared, then you know it's the chain rule, and so you can write cosine of x squared times the inner derivative, which is 2x, and now we have the derivative. So if this is the set of all term functions, if you take one of these term functions and you derive, you will be back in the set of the term functions. Now let's talk about integration. If you want to integrate, then you do the same or you do the opposite of what you did when deriving. Then in this case you are looking for the antiderivative. And please tell me, what is the antiderivative of that? Which function derived is sine of x squared? And this is a really very hard question, and I don't know this antiderivative. There's one trick using potency series, then you can do that in that case. But apart from that, the normal term functions will not give you the antiderivative. And this is only one example. There are several more. What is the antiderivative of e to the minus x squared? This is an important function that has to do with the Gaussian distribution function. And plotting this function, this is not very hard. And if you want to integrate, let's say from 0 to 1, then you are looking for that area, and that does not look like a hard problem. But it is a hard problem because nobody knows the antiderivative. So if you're interested in that definite integral, then you need some idea. Or also that function sine divided by x, and then this function looks like that, and here integrating from 1 to 5, find this area. How large is this area? And here also you don't find an antiderivative. You don't find an antiderivative, you don't find an antiderivative. This is not possible. So we have really a big problem if we are interested in the answer to these questions. And so we are really looking for an algorithm, for an idea how we can do that integration. And what will we get? We will get an approximate value. Okay, and if we have a term function, then we're asking how to integrate, and also for sample functions, we ask the same question. And what will we do in the next videos? In the next videos, we will talk about several ideas, and we will start with the trapezoidal formula. We will start with the trapezoidal formula. This is a very easy idea. It's the starting point for us, but this starting point alone is very powerful. It's not only for didactical use that we start with that idea. It starts with an idea which you can apply, and this is a good solution if you are interested in integral values. So we will do trapezoidal rule, Simpson, Newton-Cotes, Gaussian quadrature, Romberg, and maybe I forgot one. And then we will really have some powerful tools, And we will understand what happens if you are asking Octave or MATLAB. There is a command, this is quad or integral, and what's going on when you call that, and what can go wrong if you apply these algorithms. So this was the overview. Let's work on the next videos.